Welcome back to our MVA, where we're talking about blockchain. On this module, Cale is going to introduce us to a quick little walkthrough of how Truffle works. So we'll turn it over to Cale.
Sure. And when you get started with Truffle, we have a couple different vectors. It used to be you had to kind of go out and look at the docs and kind of figure out what to set up. The demos that are out there on the read the docs for Truffle actually reference using TestRPC. And if you've been through that, there's a bunch of different steps you need to do there, but we try to kind of streamline that a bit with Azure. So if you take a look over here in the portal, it's actually in the portal now. So in the marketplace, so if you click on that little plus sign, let me zoom in there a little bit so you can see that. This little plus sign up here in the corner to create a new asset inside Azure. And basically in here, we're just going to search for the word Truffle. So if we search for Truffle up here, we'll actually see it come up in the search results here. We can click on that, and you can actually see over here that it actually describes kind of what the product does, as well as what happens after you get this thing running. It's actually going to generate 10 accounts, so it's going to have a test RPC on it already pre-installed for us. It's going to have Truffle and all the dependencies already installed. So we're off to the races. We can start developing in a couple minutes after this thing deploys.
Yeah, and that's a great example of how you can leverage the Azure infrastructure to really bootstrap your developers. You don't have to worry about getting everything set up on your local PC. You can also use that same marketplace image from Truffle and put that into DevTest Labs so that you can spin those up, spin those down. So great use case for that. So let's keep going.
Yeah, and in here, just to kind of demonstrate what we're talking about from a one-click perspective inside Azure, when we go into the portal, I'll go ahead and zoom in here again. We basically just have these steps over here that we need to roll through. And each one of these, we're just going to have to answer a bunch of questions about what do we want to name this thing, and do we want it, what kind of disk type do we need? Do we want high performance, or are we okay with something that's maybe a little bit slower and it's cheaper?
What are some of the general guidelines around this type of environment?
I mean, Truffle has very little overhead, so you can run these on slow machines. I wouldn't recommend putting them on A0s. I mean, I rarely recommend anybody put anything on A0 unless you're just testing something really quick. My general rule of thumb is to go with like a D2.
Okay.
That's just a standard one to use these things. It is a good note that you talked about DevTest Labs. One thing we should be doing is making sure that we shut these down at night, especially if it's for a developer, because we're wasting money, having the thing run.
Absolutely, and the new timer features are available to all virtual machines running in Azure, so you have the ability not just in DevTest Labs, but in any virtual machine to auto-shut those things down at night.
Great point. Yeah, so I'm not going to go through this. You could fill this out yourself. I actually pre-provisioned one so that we could get through our demo a little quicker here. And so on my desktop now, inside Azure, I actually have a Truffle image running here. You can see it right here. This is running Ubuntu 16.04. And it's got everything installed. So if I pop up and I have an SSH console here directly in this box, already logged in, and simply if I just want to start running a demo with Truffle, I can just start up TestRPC. Now what's happening behind the scenes here, as we mentioned earlier, is if you look at, I have the font exposed here so you can see it a little bit bigger, but basically we have 10 accounts here that got created automatically for us. We talked about the Genesis block. You can think of that like this one. So this is running in memory, but it actually just generated 10 accounts for us automatically.
And did it populate it with Ether and everything?
Yeah, the first one has some Ether in it, but the other ones don't.
Okay.
And that's what we'll kind of demo in this deck, just to kind of show that you can transfer Ether from one to another. Remember that?
And are they already unlocked, or do we have to go through the whole process of unlocking them and everything?
Yeah, in TestRPC they're unlocked because it doesn't function the same as pure Ethereum. But yeah, you could run the same demo pointed at Ethereum, but obviously you'd have to unlock the accounts if you want to start moving, doing transactions with them.
Great.
So basically, we have to leave this run. So if you look at the bottom of this thing, it actually shows you these are the mnemonics that it used to create that. This is like a recovery key, as we mentioned before. So these are using the Ethereum wallet in order to build those. And you can see it's listening on 8545 right now. So if we come over to Truffle, and I'm just bringing up another SSH into the same box, and all I need to do to start working with this is I just make a directory, and we'll just call this the MVA demo. And then we'll go into that directory. And then we'll run Truffle init. Very much like anything in Node.js, we do a lot of inits. Truffle's built heavily on Node, so you see a lot of...
Creates a scaffolding for us.
Yeah, so if we take a look out here what actually got created, we actually created an app folder. That's where our app code's going to go for our test application here, just scaffolding out a simple HTML and JavaScript application for us. The contracts are where the smart contracts are. The migrations has the scripts that enable us to do the auto migration features that Truffle has for DevOps. The test is the unit test for these contracts, and then Truffle.js is kind of important. This is the main configuration for Truffle. So if we take a look at that real quick.
Kind of describes the application as a whole.
Yeah, you can see that when it does a build, which is the entry point for the application, the index. It also has where the CSS and the app.js and the images folder. So just describing the application. And then from an RPC perspective, this is where it's going to talk to a blockchain. So
Okay.
you can think of this as JSON RPC. So right now it's pointed to local hosts. And actually, if you're running this in Azure, you don't want that. So what you want is to be able to put your endpoint in here. Whatever the name of your, or the IP address of your machine is. So how do you find that? You come back over to the Azure portal, click on your machine that you spun up, and it's right here. You can get your public IP, and you can get a DNS name if you have one set up for it. So I'm just going to grab the public IP here. We don't have any dependency on naming here. We got this cool little thing in here where you can just hover over it and grab it quickly. Pop that guy in there. So now we're pointing to ourselves, because if we pointed to local host, and this thing's running in Azure, obviously it can't resolve. So it's not going to know what to do with it. So once we have that all fixed up, now we can actually get started with our Truffle. Now let's take a look at the contracts. You can see there's a few of them in here. So we have this ConvertLib, we have Metacoin, and we have this migrations. The migrations, and you can look at these in your leisure, but the migrations is basically a contract to keep track of when we're doing migrations, which addresses point to which smart contract. Just allows us to do that DevOps type operation to be able to detect when one changes, which ones we need to deploy.
Okay.
Dependency graph kind of.
Yep, absolutely.
Metacoin is the core of what we're building here. So we're going to build this token system, and that's what you're going to see here demonstrated in a second. And ConvertLib has a dependency on that.
Okay.
So we're going to see that actually play out. So if we just did a Truffle compile, it's going to basically look for any soul files and compile them for us. So this is going to use the standard SolC compiler. It's going to go out and compile them. Now, one thing to keep in mind is it doesn't matter what order they are when they're being compiled, because it's not going to go try to execute anything, right? So it's just going to strictly do a static compile to make sure these things are actually syntactically correct.
Okay, so you're not looking at logical errors. You're just compiling it into bytecode, and then you're done.
Correct.
Okay.
So we do that, and we actually have those out there. Now, the interesting thing is when you start to get into the migrate. So if we did a Truffle migrate right now, what's going to happen is it's going to look and see what we've deployed so far. It's going to see these 3 smart contracts that aren't deployed to this test RPC, our blockchain, and it's going to go ahead and deploy them for us.
Okay, so even the first deployment can be used as a migration.
That's correct.
Okay.
So if we do a Truffle migrate here, what we should see is it detects some things. Now I don't need to zoom in here, but I just wanted to point out a couple things. You can see that it's calling the migration, so it's deploying the migrations contract, because that's what's going to keep track of our state of basically what's deployed, what's not deployed. And then it's going to go ahead and detect the ConvertLib needs to be deployed first, and you can see this linking command right here. So there's not an actual linker there, but it's basically establishing that, because when we establish the ConvertLib up there, which Metacoin has a dependency on, it's going to make sure that I laid ConvertLib down, get the address for that, inject it into Metacoin, and then deploy Metacoin.
Okay, so it helps build the dependency tree.
That's correct. So now we have all those deployed out there, and if we popped over to our little console over here, where we started up our test RPC, we see we got some action over here. We see some transactions actually came through. We can see the block times that are on those, and again, this is an emulation, but it's actually simulating exactly. There's the gas usage, there's the block number, this is block number 2, gives you time and date stamps, tells you everything that's happening over there. So we actually deployed a contract. You can see here, contract created, see the address of where these things got created. So really cool to get started when you start building up these applications, and not a lot of fuss. You didn't see me building any kind of blockchain here.
Right.
I'm just getting this thing running so that I can actually develop something. Now after that, we would basically just do a Truffle build. And by default, while that's doing the build, it's building the application up. I'm going to pop back over here and show you a couple things about Azure that are pertinent to these blockchains that you might want to be aware of. So one of the things is, in this case, we did that test RPC, remember, and how do we get those things exposed? So as I'm clicking through here, I'm just showing you basically, if you go into your virtual machine and go into your network interface, let me zoom in there a little bit. So you would go into this network, you go into this network interface section, which is basically the NIC for your VM. You would click on that NIC, which is up here. And then you would click on this network security group over here, which is essentially a way for you to expose ports, right?
So you're going to be exposing the ports to that test RPC instance that's running right now.
That's correct. So we have this here, and there's also, I'm going to show you another one that we're going to expose because we're going to need it here in a second. The actual application, the DApp itself.
Okay.
So over here, if you take a look, when you use this image, and this was built in the Marketplace, so it's already set up for you, you can see in here that we basically have all the ports open that we need. So here's our inbound security roles. You can see we have SSH, which is how we're kind of managing the box, and we're logging into it. We have Truffle Web, which is port 8080, which is what our DApp's going to run on. And then we have Test RPC, which is 8545, and that's the one for our RPC connection to simulate the blockchain.
Okay, so that's our blockchain emulator.
That's correct.
Okay.
So in the future, when you start deploying these things out, these things will make more sense, but you just keep in mind that you do have functionality there in Azure to expose those things either externally or even internally. Maybe you don't want to expose it to public internet and you want to attach to a site-to-site connection or something like that into Azure and do your testing that way.
Okay.
So once we have our Truffle build done, basically the last step we would do is do a Truffle serve, which has a little web server built in here to actually run our application for us so we can see it actually functioning. So you can see that we went ahead and served our app out. You can see it's listening on 8080, again, because that's the one we exposed.
That's our DApp.
And, everything completed without any errors. So what we should be able to do is pop up into here, and let's take a look at it. And I need to get the IP address again.
While he's doing that, it's important to remember that you've got several different steps just to do that Truffle. You've got a Truffle compile, you've got a Truffle migrate, Truffle build, and then Truffle run is actually what spins up the DApp itself. That's going to be the UX or the front end that gets built along your command line chain. On the other side, that test RPC, that's simulating your endpoint. So you both have a web server and an Ethereum network endpoint out there in your environment.
Right. And so then when we spin up our application, we can see up here we would have a send to, and we would have an address that we could actually send these to. So we could use kind of our test RPC that we had running over here before, and we could actually send data over to there. Now, one thing I wanted to show you is when you start using this thing, you'll actually see, I guess I'm logged in. I'm not seeing any ether right now. We might take a breakpoint here right now. Just 1 second, because I don't know what's going on here. I should see 10,000.
Yeah, you have meta.
Okay, so we're back over here, and you can see now that when we start the application up and we go to port 8080, let me zoom in there and show you that we're just going to the IP address of what's provisioned up there in Azure, and we're going to port 8080 for our DApp. We actually see that we have 10,000 meta coins here now, which is a token system, basically.
Lots of money.
Here. Yeah. So what this is doing behind the scenes, and I'll show you the code here in a second, is it's actually just reading what accounts exist on this blockchain, our test RPC, and which... So we're reading count 0, basically. Remember, we had 10 accounts? So we're reading the first account that's in there that got minted with this meta coin.
Right.
Now, if we went and looked at any of the other ones, they don't have any meta right now, and I'll show you that in a second, too. But what we want to do is basically give them some.
Let's give them some meta.
Yeah, we want to give some of those. So let's say we're going to give 10 meta to one of the other accounts.
Okay.
Now, how do we know the accounts? We got to come back over here and look at our test RPC, and we'll just grab one. So let's grab the second guy, this guy. We just grab his address, we bring it over here, pop it in. What we should see in a second here, and you see it, let me see if I can zoom in so maybe you can see it better, is you can see that our meta dropped because we actually executed our smart contract. And you see it was instant because basically we're running a test RPC.
Test RPC, one node, nothing to synchronize.
Cool. Yeah, so what happened was we took those 10 meta, we transferred it to a different account. Now, how do we see that actually succeeded? We actually saw the debit happen here, right?
Now let's see it on the other side.
Yeah, correct. Let's see the other side. So how do we do that? Well, let's pop into our Truffle node here again. Remember, it was running our web server. And I can tell you that it's in the app itself. And if you look in the JavaScript folder, and this is just a simple example, but it's something that you can use to start working off of. If you pop open the app.js, which is kind of the core code, it's kind of the core functionality for the application. And if you scroll down to the bottom of this, it's just a bunch of JavaScript code, and it's using Web3.js to actually talk to it. And you can see down here, when the app starts up, it's just going to go read account 0.
Okay.
And that's what it's going to display on the screen. So instead of reading account 0, let's display account 1, which is the second account actually in the system. So we'll just pop that open with VI, change that, go back over here and run our Truffle.
Migrate.
We don't have to migrate anything.
No.
Remember, we didn't change any smart contracts.
Oh, you just changed the JavaScript.
Correct.
And then
Our
you just,
dApp.
or your dApp. So you just relaunch that Truffle web server,
Correct.
and it should have 10.
And there you go.
Awesome.
So if you look at the screen now, you can see we're logged into the second account, and we actually have 10 meta. So proving that it actually functioned and actually transferred the value the correct way. This is a very simple example, but it's just showing you some of the power of what happens with Truffle. We could actually walk through and change things in the smart contract, and you can actually see it go through. But I recommend you guys check it out and take a look at it. It's very easy to get started with.
That sounds great. So thanks for watching our little demo. We'll see you next time.
Thanks.